Hello guys, today we'll be taking a look at skeleton word equations. So today we'll learn what are skeleton and word equations. We're going to learn how to convert skeleton equations to word equations and how to convert word equations to skeleton equations. So let's get right into this. So what are chemical equations and most importantly, what is its purpose? So essentially, a chemical equation is a symbolic representation of a chemical reaction in the form of symbols and formulae. So essentially, it's a faster and efficient way to describe chemical reactions. And by using these specific, chemical formulas, symbols, we get to know the number of moles or molecules involved, what type of elements are involved, what type of substances are formed. So this is very important. So that's what the main purpose of chemical equations is. So here we have our two formats that outline chemical equations. We have the skeleton and the word format. Number one, skeleton equations. They're the most used and the most common form of chemical equations. These are the ones that you use for balancing equations. Whenever you get any examples in school, this is the ones that you guys are going to be using the most. Essentially, it uses chemical formulas, subscripts, coefficients to describe and outline a chemical reaction. It uses brackets to show the state of element or compound. As you can see, you have the coefficient and the subscripts that show the number of the specific molecule, the number of molecules present for that specific element or compound. Then we have the states of matter that are outlined in brackets. So we have AQ, AQS, G, gas, S, solid, and L, liquid. The second format of a chemical equation is word equations. So they're not as commonly used as skeleton equations, and that's because they're long, they're inefficient. They still give the same information as skeleton, but skeleton is shorter. You can do that way faster than this, and this is just lengthy and inefficient. So the scientists never preferred using these ones. However, they're still important to learn. There's no numbers used, and as you can see the example, this is what the format looks like. So you have the reactant. So you have the reactant, the quantity of the reactant and the state of the reactant. So you have 2 moles the quantity of aqueous. You have the state, and then you have the reactant itself. Then it says the statement are reacted with, again, quantity, and then you have the state of matter, and you also have what type of element to form, again, quantity, state, and what's formed. And now we can move on to converting. Now we're going to learn how to convert word equations to skeleton equations. First thing we have to do is read this out loud. So 1 atom of solid zinc reacts with 1 atom of aqueous copper sulfate to produce 1 mole of aqueous zinc sulfate and 2 atoms of solid copper. So this is what we're going to do now. We're going to look at that information, just write it out in symbols, subscripts, and the brackets for the state of matter. So first of all, we have our 1 atom of zinc. So we would go 1 zinc, and the state of is solid. And then we would say, okay, it reacts with 1 atom of aqueous copper sulfate to produce 1 mole of zinc sulfate aqueous plus, because it's the and, 2 atoms of solid copper. So that's basically it for converting word to skeleton equations. So converting skeleton to word equations. So we have essentially the same thing as we did before, just the vice versa. So instead of extracting information and writing it as symbols and coefficients and subscripts. We are just using the subscripts and extracting information to write out in words. So this is what we're gonna do now. So we're gonna read it out. So 2 moles. So we have 2Na. So 2 moles of aqueous sodium reacts with 1 mole of chlorine gas to scroll down to produce 2 moles of solid sodium chloride. And now we can actually compare these two. So 2 moles of aqueous, okay, 2 moles of aqueous sodium react with, so plus reacts, we have that with 1 mole, okay, we have the 1 mole of chlorine gas, okay, we have the chlorine and the gas to produce, okay, produce 2 moles of, okay, we have the 2 moles of sodium chloride, and that too solid.